Okay, cool. Hey everyone, great to see you. I see a bunch of familiar faces. First half of this presentation, if you've seen me give a talk before, you might have seen already. And then second half, I'll be going into some kind of deeper builder updates on Vana. Quick intro to me. I'm Anna, co-founder of Open Data Labs, which is the research and development company behind Vana. I first got interested in crypto through mining Ethereum pretty early on. I was really interested in central banks, actually. Like, I had a picture of Janet Yellen in my high school bedroom, and then worked at the Fed in high school, was like, currency is central to it all. Got to MIT, learned about decentralized currencies, and started going and getting GPUs from dumpsters and mining with them. So that was in 2015, kind of early MIT Bitcoin Club, and just got really fascinated with the power of decentralization and how you can rely on cryptographic systems to build kind of large-scale things that would usually have to be centralized or maybe even better than what a corporation could do. I then got interested in AI through some research that I was doing at CSAIL, which is MIT's AI lab. In the early days, it was kind of called natural language processing. But basically, I always wanted more and more data to train AI models on. And I saw a lot of my friends going and working at big tech companies because that's where the data was. So what we're doing with Vana is really kind of using that decentralization to take data out of walled gardens. Just to get a sense, how many people are pure AI people in the room? Okay, versus more crypto people? Okay, nice. Might be slightly crypto heavy, but I'll make it a little more AI. Okay, so ultimately AI models are kind of only as good as their training data. Now, these days, a lot of the foundation model companies, they don't release exactly what data things are trained on. So this is the GPT-3 training data, but it's pretty representative. What you can see is that the majority of it is common crawl. And what that is basically scraping the whole public internet, right? So also, if you've posted on Reddit, you might have already helped train AI models. But the majority of the training data that people use today just comes from public information. Something a lot of people don't realize is that most data is private, not public, right? And I think often when you think about an AI model learning, I like to picture almost like a kid growing up and getting memories and kind of experiences throughout the world. And so if you only let it experience the public internet, that's actually a very small % of overall data and information that exists. So it's less than 0.1% of overall info. And most internet data requires permissions or sign-in to access, which is hard to access to be able to train AI models on today. One of the things that we're running into is called this data wall, right? And I'd be open to debate some of the AI research people on some of this too, of kind of, hey, is it a data wall from a quality perspective, from a quantity perspective? But generally, as we're trying to make AI models better and better, so this graph is showing kind of as AI has gotten better, we started with GPT-3, GPT-4, Llama 3. One of the ways we made it better is by scaling compute. But when you scale compute, you're actually also scaling data, right? So if you want to keep on scaling things, you need more and more data. And what the data wall refers to is we're pretty much out of training data if you're just training on publicly available information. So Llama 3 is trained on 15 trillion tokens, not like a crypto token, it's like a word, which is pretty much the same as FineWeb, which is the high-quality subset of Common Crawl. One, it's very impressive that we've taught AI with 15 trillion words, right? That's a huge amount of information for AI to understand. But if we want to continue this graph and kind of continue to make AI better and better, we need to find somewhere to get more data. One thing I like to mention too, now that DeepSeek has come out, is that the data wall is kind of an issue of both quality and quantity. So I think what DeepSeek did was really interesting, where they kind of overcame things more through quality. So they had a team of PhDs generating really high-quality cold start data. This is one of their job postings from their parent company. But basically, they focus a lot on data collection because it's very important to them. And that's really what matters to build better AI. So companies have realized, hey, my data is really valuable because it allows people to build better and better AI. And they have been able to make a lot of money from that, right? So Reddit's earning $200 million from selling data. PhotoBucket, $1 to $2 an image. Apple is buying data for $50 million. My co-founder, Art, used to work in data sales, selling data to big tech. So this is something that he's been working in really closely for a long time. A lot of people don't know about this massive data sales industry because people don't like to publicize the fact that they're selling your data. It's kind of uncomfortable. But alongside the shift, basically the internet is becoming less and less open. So maybe you all remember like Stack Overflow, Reddit, like they're all changing their API terms of service. So it's actually harder to get their data because that allows them to charge more for it. So we're kind of in this situation where the siloed walls are growing and growing because the companies are realizing how valuable their data is. Something that often maybe people just don't think about or don't realize is that they have full legal ownership of all the data that they create. So in the same way that when you put your car in a parking lot, the parking lot doesn't own your car, right? They can't randomly take your wheels. They can't refuse to give you your car back. When you put your data into a platform, you still retain full legal ownership. So that's true for every platform, Tesla, Amazon, Instagram, 23andMe. Your data that's sitting with them is still legally yours. You signed kind of the terms and service when you check that box that allow them to use your data for different things, but you are that legal owner. If you want a fun exercise, if you have used an Alexa in the past or Instagram, you can go export all of the voice recordings ever. It's a little bit creepy, but it just shows that kind of all of the data is there. If you're a California resident, Instagram is one I really recommend because they give you not just your posts and your photos, but also the AI-generated labels of you. So one label they had put on me was stressed but not depressed. And it's just actually hilarious. They'll give you a list of 300 things. And that's really valuable for a lot of different companies, right? A lot of people are like, oh, that's Instagram's data, but actually it's yours. So you can always get it back. So it kind of offers this opportunity, right, where as platforms are kind of locking down their data, I think a lot of people in Web3 might be familiar with this image of walled gardens, right, where you're trying to constantly build up a bigger and bigger walled garden if you're a big tech company. What Vana does is basically cuts through those walled gardens using the power of individual data rights. So each user can go and export their own data to take back ownership of it. Some of the core concepts to enable this are, one, non-custodial data. What that means is that on Vana, you can manage access to your data just like your funds. So you're basically the one controlling your data by signing transactions. One analogy that I think is helpful here is similar to how with Bitcoin and Ethereum, you are your own bank, right? Bitcoin isn't a bank for you. With Vana, you are your own data processor. So you're not trusting anyone to custody your data. You're in full control. If folks are familiar with Solid Project or Urbit, which are two non-crypto, more federated projects, you might notice some patterns in the architecture that are similar. Solid Project in particular, I'm a huge fan of. And then the other thing to mention is that just my data on its own is not that valuable, right? And so if I only have my data, that might not be enough to train an AI model. Where it gets valuable is if we kind of all come together and pool our data. The risk of doing that is that one person could say, hey, I'm going to try to take control of the data set and add a bunch of data pretending to be lots of people. So to prevent this, Vana runs using proof of contribution. And that ensures that the data that's coming into what we call a data liquidity pool, basically just a pool of data. You might have heard it talked about as a data DAO, like a labor union for data, just kind of aggregating data as a resource and then governing it as a group. So proof of contribution ensures that kind of only high quality data is allowed in. So I'm going to go through a bunch of different applications that are possible with self-sovereign data on Vana. The one that people might be most familiar with is data DAOs, which is kind of this primitive on Vana built on top of a data liquidity pool, which lets a group of people govern data. And then I'll talk about DataFi apps, which are basically financial applications powered by data tokens. Some of the AI applications that are built on top of the different data sets available on Vana. And then data portability. So because your data is attached to your wallet, you can log into any application, basically bring your data with you. One caveat, I put 2 construction emojis there because it is not necessarily ready for kind of general use. But if you have a specific application, we're happy to work with you on that. So I think, examples are really helpful. 2 of the data DAOs I like to talk about. One, the Reddit data DAO. So they have 140,000 users who contributed their Reddit data. And now an ex-Google Brain ML engineer has actually trained a model on it. It's mostly just good at shitposting because it's trained on Reddit data. But it kind of shows you that full end-to-end workflow, right, where people can pool their data and then you can create an AI model that's jointly owned by everybody. The other one I'll mention is the 23andMe DAO, which is working to buy 23andMe and make it user-owned. That is a very ambitious goal. I mean, the 23andMe, the company, I think is at maybe $75 million to $100 million market cap. So it's not insane. But I think what that's a good example of is this idea of really a data DAO is kind of like a union, right? It's not necessarily financial what you want to do with the data. Your goal, in the case of the 23andMe DAO, could actually be to prevent 23andMe from selling your data, right? But having that collected data is really what gives the group of users power. So now kind of getting into some more technical detail. Each data DAO, which is from a technical perspective implemented as a DLP, stands for data liquidity pool, they define their data set structure and proof of contribution. So this is sleep.fun, one of the ones focused on sleep data. And what you'll see is that the data is structured, so you can kind of consume it across users, and you also know what data people are actually contributing. A fair amount of work in building a data DAO is in implementing proof of contribution. And proof of contribution runs as Python code on a set of TEs to ensure data quality. Some clients use ZK and ZK-TLS as well. So if you're thinking of doing something like that, the Amazon data DAO is one of the ones to pull up that's using that. And then all the proof of contributions are publicly available. So as someone consuming the data, you know what guarantee you have about the data. Something I'll mention too, I'll actually pull up an example of this as well. So the data token mechanics, basically each data set has its own data token, which is created through a data liquidity pool. And then contributors earn data tokens by adding verified data, and companies and researchers buy and burn data tokens for access. I think it can be really helpful to see kind of what this looks like in practice. So let me pull up one of the data DAOs. This one is focused on financial data. And so when you are creating a data DAO, you're basically having to map something that is not fungible, which is everybody's data, right? Necessarily it's different, to something that is fungible, which is like a token that kind of represents ownership. The question you're trying to answer is like, how much is my data worth relative to somebody else's? And so in the case of Inquirium, what they've done is they basically have based on your, like how much data you have and how early you contribute, you're rewarded. So like the first 10,000 users to contribute data, they support Coinbase data and Binance data, earn like twice as much as users 10,000 to 100,000. And then they also scale it based on your trading volume, based on your activity. I think they also have some kind of loss recognition thing where if you've lost over $1 million in crypto, they give you more points. I don't know what the rationale, but maybe it's like interesting data for them to have. So yeah, if you're implementing proof of contribution, I'd highly recommend looking at the other data DAOs and how they do it to understand how best to kind of verify data. Because this is what is preventing a Sybil attack, right? You want to avoid allowing people in who aren't actually contributing high quality data. And then, the other thing I'll mention, so there are kind of incentives for the top 16 data DAOs. So if you are in the top 16 by stake, you actually earn for onboarding data to the network. And so there are a set of performance metrics that determine these rewards: data access volume, data quality, and kind of amount staked. Here are some other data DAOs I'll mention. So YKYR, they have a browsing extension you can install that basically is kind of trying to build like decentralized Google Analytics. AutoDLP, if you have a Tesla, you can join AutoDLP. Some of the folks buying data from them are car battery companies who are kind of trying to understand how car batteries degrade over time. And then Prime Insights, which is the Amazon one. Amazon in particular is kind of interesting because I think that a lot of companies in the US are very threatened by Amazon as this giant company. And so we've seen that the ability to access, like, hey, what are my customers buying from my competitor, is really interesting for certain retailers. So all of these are their own teams. Like AutoDLP is a venture-backed kind of company. Some of the other data DAOs are fully bootstrapped, but it's a really fun design space to build in. I often joke that I wish I could clone myself and just build data DAOs all day. So if you want to build a data DAO, treat me as an extended member of your team. If you want to build one, this is a link to a data DAO template that makes it kind of forkable, easy to use. But basically what you want to do is pick your data source, kind of how users will contribute, and proof of contribution. And then implementing that. The bulk of the work is in Python, that proof of contribution, and in building an interface for users to contribute data. If you don't know Solidity, that's actually OK. You can just use the template contracts and deploy them. And then just sort of a lot of the mapping around the data tokenomics happens in Python. Then register and launch your data DAO. It's a permissionless network, so we're at the point where I actually don't know all the data DAO teams anymore. But yeah, you can register, and then you can compete to get into the top 16. Most of the teams are 2 or 3 people. I think the initial build takes a few weeks, but you could create a template one in just a few hours. A few that I'd call out that I think would be interesting right now. One, TikTok, especially with kind of the uncertainty around what's going to happen to TikTok in the US. iMessage, and then also medical records. OK, so now moving towards DataFi apps. What this is referring to is basically building on top of data as an asset class, right? I think the closest comparison that is kind of widely spread today is probably in oil markets. Like, you know, when companies consume a lot of oil, so they actually buy oil futures, right? And you kind of have whole markets around pricing oil. I think that's the sort of ecosystem that I see popping up around data. There are some early versions, so there's kind of data trading, data derivatives. There are a couple of DEXs. There's actually, they're not live yet, but there's a data perps platform, Perp City, which kind of allows you to leverage trade data. I don't know what they're thinking actually exactly is there. But yeah, that's another one to call out. And then there are some plugins where AI agents can basically trade their own data. One thing, if you're deep in the Vana ecosystem, you'll know what this means. If you aren't, yeah, this might not mean anything, but that's OK. So VRC 13 is one of the major upgrades where the DLP incentives will start going directly to data tokens. So basically bought and put into a DEX pool. And I think that will really accelerate this DataFi ecosystem. So next I wanted to talk about, OK, so data DAOs are bringing data in, right? They're like onboarding data into the system. Data tokens are kind of the financial mechanisms built around that. You can build different financial primitives on top of that. But then when you have all this data in the system, you can build like all sorts of things. One of the main things is you can train AI models with the data. So on mainnet today, it's relatively it's a little bit cumbersome to access data, so yeah, you can basically go through a manual approval process, kind of manual pricing for data DAOs. It's just one data DAO at a time right now, but you can connect data across different users. One of the companies that's doing that is Flower AI, which is a federated AI company. They're based in Germany, and they're actually doing full pre-training across 3 different data DAOs, like with a 1 billion parameter model. And then upcoming is automatic API access. I'll actually give a preview of what that will look like. So let me just pull this up. I'll be previewing data from the Spotify data DAO, which is focused on Spotify data. The reason why Spotify data is interesting is that Spotify's API terms, they've changed them recently, you're actually not allowed to use the Spotify API for any AI applications. And so what we've heard from developers is that that's really limiting towards what they want to build. So with Vana, you're able to access that data across a bunch of different users and be able to kind of interact with it. So this is the query interface. This is just kind of a preview, very developer preview. But what it allows you to do is basically write a query and get like user listening stats, right? You can see that the data is kind of fully structured and you know what's coming. And then the sorts of applications that you can build on top, I'll just pull this up. So this is kind of pulling all the data from across Spotify and kind of getting some aggregate information. You can also train an AI model, but I think this just kind of shows, OK, what's actually possible to run. And right now, only kind of aggregate queries are supported and AI training. And the reason for that is that when you work with data, a lot of the value comes from the fact that you can gate access to it, right? So it's very important that you actually keep that private data private. We call this internally like the double spend problem for data. And that's essentially referring to the fact that like, if I sell you my data, like how do I know that you're not going to then sell my data to someone else? So the way that we handle that is through these secure compute environments where you can only run aggregate queries or train AI models on kind of a whole pool of the data. Oh yeah, so if you want to access some of the data, you can go browse all the data DAOs, and that just shows you like all the different data sets that are available. So we can pull some of them up. There are a bunch of sleep, kind of like decentralized science, or maybe even just science, biohacker type ones. So there's a location data set, Google location data set. Actually, there are 2. It's a competitive environment, so sometimes there are 2 different data DAOs focused on the same data set. There's a synthetic one. There are a couple of Telegram ones, 23andMe, Sleep.Fun. There's a mental health data set. And so, yeah, those are just some examples. There's also a blog post I'll link to later, which kind of has a wish list of different data DAOs that I think could be interesting to build. OK, and then last, I wanted to talk about data portability. So when you connect your data to Vana, you're connecting it first to your wallet in a kind of copy that you control. It's encrypted with keys that you fully control. And then you're delegating access to the data DAO. And you're saying, hey, the data DAO can also basically control a copy of my data. If they vote to do something with it, they can run the approved code on the data. But what's cool about having a user's data connected directly to their wallet is then, I guess in this case, I can connect my sleep data, my mental health data, and my 23andMe data. And I can log into a health application and bring all of that data with me, right? So it kind of allows for this portability of data across different applications, especially for personalizing AI. So yeah, here are kind of all the different categories we went through. Data DAOs are by far the most kind of self-serve. That's where the vast majority of adoption is. And then if you want to build especially AI apps using data access, feel free to come talk to me about like your dream data set, kind of what you'd want to train on. We can see if a data DAO already has it. And then if you're building a consumer product, probably that's when data portability might be most relevant to you if you want to be able to personalize your application to a particular user. If you want to dive deeper into Vana, we have a developer Discord. If you're kind of actively building in the space, this data DAO wish list I mentioned earlier. There's a white paper if you want to kind of go into some of the more high-level design and how things work. And then there's a builder site. And we also have an upcoming hackathon, which starts on Wednesday. So if you want to participate in the hackathon, this is a link to get started as well. Great. Thanks so much. Happy to take any questions. Yeah.
I'm sort of get how do you value or like value the data? Like because they're all like it seems like a lot of different kinds of data sets within Vana. So can you elaborate a little bit on that?
Yeah, it's a really hard question, right? Like how much should my Spotify data be worth relative to your Facebook data, right? And so the way we've solved it is actually not by saying, hey, we know exactly how much every single data point is worth. We actually have a market-based mechanic, right? So what you need, there are data tokens that are specific to each data set. So that solves the problem of like how much is Spotify data worth relative to Instagram data. But it doesn't yet solve the problem of like how much is my data worth relative to yours within a same data point. So that's solved through proof of contribution, which is actually, that's the Python code that's basically measuring how much is my data worth relative to yours. And it depends on the data source, right? So in the case of Reddit, they do it based on the square root of your karma. So if you have more karma, your data is more valuable. For 23andMe, they just do it equally for everybody. So if you kind of pass their checks of like you've actually used 23andMe, then you're able to join. I actually will pull up some other, this is still, I don't think any data DAOs have this in production yet, but this is some research that I think is pretty interesting. And what it is, it's basically called like model influence functions. And so, I'm just trying to zoom in. OK, so what it is doing is you basically take a trained AI model, I'm trying to show these handwritten digits here, and you show it a new data point, and then it returns how much information that data point contains that the AI model didn't already know, right? And so if you're familiar with the MNIST data set, which maybe the AI people in the room are, it's just handwritten digits. These are the digits that are the most influential, and often it's the edge cases, right? It's sort of the cases where the AI model might not quite know. But I would say this isn't a perfect solution. And the reason for that is that you could have an edge case that actually is just really bad, right? It teaches the model a lot because it's bad information you don't want it to teach. So I can actually go into a little bit more detail on proof of contribution, too. Let me just pull this up. And the reason why this is kind of the core problem to solve, right? To actually make a data market work, right? You need some way to be able to kind of relatively value data. So we have kind of guidelines for how to implement proof of contribution. And I can actually walk through the criteria we like to have people check. So the first is authenticity. So what that means is that the data actually comes from where you're saying it came from. So this is a sample implementation with ChatGPT. Basically ChatGPT exports. And the way you check authenticity is that when you get your ChatGPT download, it's like via email and a link. And so you're checking that the link actually came from the server where ChatGPT sends exports from. The next is ownership. So I want to prove that this is my ChatGPT file, not somebody else's, right? It could be a real one, but maybe it's someone else's. So the way that ownership works is that a user actually has to kind of connect. You can basically check in the email if that email is actually theirs and they control that email. So then you're able to check, okay, this is actually Anna's ChatGPT data, not just valid ChatGPT data. Then you have a question of quality. I'd say this one probably varies the most across different data DAOs, right? If you're evaluating quality on audio data versus image data versus Tesla data, it can really depend. So in this case, they're using an LLM, but you can also use kind of social-based scoring. So if you have more LinkedIn followers or Instagram followers, then you can be rewarded more. And then finally, proof of uniqueness. So if you imagine that you're building a data set of like tweets, for example, if there's somebody else who tweets just like me and they already joined, then my data on kind of the marginal value of it might not be as high, right? Because the data set actually already contains some of that information. And so, yeah, proof of uniqueness is basically relative to the data that's in there, how valuable is this data set? And that, again, these implementations vary for each specific data point.
So do you see that as a marketplace already in place, or do you see that more of a features that you can solve?
No, it's kind of full marketplace. Yeah, so you can go, like, there are like 20 data DAOs live on Vana. That are kind of standalone businesses built on the protocol. So you can, yeah, go and explore them, and they all have their proof of contributions. And something we do, too, is like before they're launching, they have them on testnet, and you can see if their proof of contribution isn't working well, because it'll get Sybil attacked pretty quickly. So then you can basically check, OK, is this data actually working? Yeah?
Great presentation as always. We'd love to better understand the example you shared of the application using multiple data DAOs and a data set, and how that actually works. That feels like a huge unlock for the ecosystem.
Totally, agreed. Yeah, so I think often when people think about a data DAO, kind of they might be like, oh, the best you can do is a slightly smaller version of what a Web 2 company has, right? Like the best you could do. But actually, because you can attach data across the same user for multiple different platforms, you can actually build better data sets. So one example of this, there's like a Fortune 500 fashion company we work with that uses data for like fashion forecasting, basically what's going to be in style. So if you just buy Spotify data on the open market, per user, it's worth about 30 cents. But if you have Spotify data plus their demographics and their fashion information, that's worth $25, right? And so when you're able to connect this cross-platform data, it becomes much more valuable. The way that works on Vana is that users are basically using like an EVM-compatible wallet across different data DAOs. So that's how you can connect it across users. We're working on some stuff with kind of like account abstraction too, or maybe if you have used different wallets but you want to attach them back to each other, you can still do that, but that's still in the works. Yeah.
I'm kind of curious about the chain of custody of the user data.
Yeah.
I appreciated your answer about how it gets queried in a trust execution
Yeah.
environment and it's aggregated. I'm imagining in the step that you talked about where you can provide it to an application from your wallet, that it's just like, do you trust that app and just give them the raw data and no ZK?
Very good question, and that is also why I have like why the engineers make me put two construction emojis right here. So there are two ways you can do it. So right now, you can run it client side with the application. The problem is if the application, you can run operations client side, but as a user, you don't necessarily have a guarantee that they're not taking your data, right? And so in an ideal world, this would also run in a trusted execution environment. But the ways that applications want to work with data are so varied that it's been hard to design, okay, how do we allow this application to use a whole bunch of users' data in a TEE, not necessarily client side. So I guess the way it works today is it happens client side. And then the way it works, I'd say maybe 3 to 6 months out will be in a TE, but in a constrained environment. And then what I'll say about data access is that all happens in a TE, and that's all kind of available today.
Okay, and so that's to clarify a question. So if I connect my wallet
Yeah.
and I say I want to provide this data to a particular data DAO,
Yeah.
is there the chain of custody to get it into the TE? What is that?
Yeah, so I'll walk through kind of exact encryption steps, actually. So, okay, you're a user. You are joining, let me think of a good one, Gmail data DAO. You're connecting your Gmail data. So first, you log in with your wallet. Your wallet is you can MetaMask, Ravi, anything EVM compatible. You sign a transaction to first log in, and then you sign a transaction to get the public key that they're going to encrypt your data with. You then take that encrypted data, and you actually store it in storage that you control. Right? And so that's similar to like Urbit or Solid project, where the user is bringing their own storage. So now you have a copy of your data, which is then you write a pointer to that piece of data on chain. So that's available. Then if you want to use it for data portability, you can decrypt that data by getting back the key, signing it, and decrypting the data. So that's like the individual workflow. Now I'll go through kind of the data DAO workflow, which is on top of that. So every data DAO is going through those first steps. If you're also delegating access to a data DAO to have access to your data, then you're encrypting a copy of your data with a key that the data DAO controls, right? And then there's a key that lives in a TEE, which is constantly checking a smart contract, which says, has the data DAO approved access to the data? And only if the data DAO approves access to the data is the data decrypted, and then the operation is run on it.
Okay.
And then one other maybe small storage point is if I connect my data to a data DAO and then they pay me for it and I control storage, how do you know that I won't just remove my data? So for data DAOs that are rewarding users up front, they're holding a copy of the user's encrypted data in escrow. So that's in storage that they control, IPFS or Google Cloud. But it's encrypted with a key that only decrypts the data in a TEE if the data DAO votes. And so my co-founder comes from like a legal background. Something that's cool about this is that the user is acting as their own data processor. And so there's basically the user is able to kind of control their data and have that full kind of custody across the line. We're never acting as like a data processor or custodian.
Makes sense. Thank you.
Great, thanks so much.